Hi, in this episode we will look at how we can implement into our TODO application the database layer. Let's see how it's done in practice. Okay, open up the application, and first thing what we have to do is spin up our database container with docker compose up or start, because we already have one. Yeah, it's already running. Then we have to create a migration. If you have not seen the previous episode, there is how to do that. Migrator add to do. If I've done this in the migrations folder, I have two new files, the to-do SQL and the rollback SQL. I've already prepared the statement, which is an ID, the to-do, and the created at date and time. This will be automatically populated as well as the ID, so we have to take care about only the to-dos. And the next is create a rollback script, which is drop table to-do. If all gone well, then just run this migration, migrate, and migrated one item, so we have the table, so we can start working on the project. Last time we implemented into our internal folder the contracts, and we have a to-do repository. This is what we have to implement. Let's do that. We have the repositories folder. We already have two different implementation of this interface. One of them which is storing the to-dos in file, another one which stores in memory. Now it comes to the database. So create a new folder, call it database or data store. Then create a new file called datastore.go. Automatically names it data store. Let's say func new, and contracts and to-do repository. Already automatically imported for me. Create a struct, type, service, struct, and return the service, return, and service. We have this underline here, means that we can use quick fix and declare the missing methods, which is service add and service list. We will implement it. Just before we do that, we need a database connection. So let's do that first. In this small example, I will use this code here, and I will add the database connection here, manage opening and closing the database. In a real application, a big application, I would suggest you create the database connection somehow when you're creating the application dependencies, and pass it through and keep the connection open. But for this example, that will be good enough. Create a new function, func s service, and open db. And it should return with a pointer, which points to SQLDB, and an error in case. If I save, automatically the database SQL is imported for me. And right now just return nil and nil before I implement everything. We have to do something else as well. We need to import the MySQL libraries. It is important that we will do this import because it will be used in the background and it will not be referenced directly. I will explain it shortly. I've already prepared the import, so I just passed it here, and as you can see, there is this underline before the import statement. This is if I'm not putting this underline, the editor may remove this import and the entire stuff just won't work. So if I use the underline, I have to do that because I'm using something which is not directly referenced for the code. Then I have to use this kind of import. So, but it's still underlined because I need to load this new MySQL package. So I just do a go mode tidy. That's one of the simplest way. Tidy. I'm not thinking of something else, and it's not underlined anymore, so it's done. I can start building up my connection. I need to create a string called DSN. I copy it here because you can Google it. You don't have to remember this format, as well as I don't remember that, so I just Googled it. And this is a connection string which you have to pass when you open the database. And with this sprintf, I will use these percentages s to replace the username, the password, the host, the port, and the DB name. Simple thing what I have to do now. Let's search for the migrator, split the screen, come back here, and just use whatever I have here. Username is my user. Just a note, in the future we will update this. Password is my password. In the future we will use an environment variable. The port is the same, the host is the same, and the database name is just simple to do. And we have created the connection string. Next, we just have to open that. So let's see, db air SQL open, and the first one is the driver name, which is MySQL, and this is why we had to import the MySQL, but it's not referenced directly because it's in quotes. So that's why I have this underscore here or underline here, and the DSN is the connection string. You can search online if you want to connect to a different type of database like PostgreSQL, Oracle, whatever. You might have to use a different driver and you have to use a different format of the DSN. Okay, so we have that. Let's handle the error. If error not equals nil, then return nil, and fmt println database connection error, not println error f, connection error, and wrap the original error. Yeah, that's okay. Now, to make sure that my connection works, I will ping the database before I return with the database. So let's say if I say if error, not error, db ping, and error not equals nil, then return nil fmt error f cannot ping database, and drop the error, of course. That's the original error. And then we just can return now the database because the connection is good. Yeah, so that's the helper function opening the database. Now let's start implement the add first. We need a new database. So let's say db error and s.opendb and handle the error. If error not equals nil, then just return nil. No, we don't have anything else, just fmt error f cannot add to do, and wrap the original error. And that's all good. Then defer, close, db close. So we will close the database with the defer at the end if everything goes fine. Okay, the next one we have to do, we need a SQL statement which will add the to do. So SQL equals insert into to-dos where, not where, but to do values and the question mark. So this is our insert statement. We always using something called parameterized queries to be protected against SQL injections. If you're not familiar with this, please search online, it's very important. Okay, now we will execute this SQL statement with the following way. We say an underscore, then aired. We will not use the first parameter as right now. And in our DB connection, DB exec. And the first thing is the query, which is the SQL. And the second is any parameters we are passing, which will be picked up here. And this will be the to-do itself. Let's handle the error. If error not equals, I have to remove this because we already defined the error here. If error not equal nil, then just return the error. Okay, and we're kind of done. If nothing else happened, we just return nil. We also need to list the to-dos what we already added. So first create the result, which is a, I can use var because I can return a result, which is a string. This is the same exactly what we will return here. Then very similar, open the DB, return an error, close the DB at the end. So I just copy and paste this one. And if I'm done with this, I need to return nil and the error message. If I'm done with this, I have to iterate through, execute run the SQL and iterate through one by one. Let's see how we can do that. First, we need something called rows and error and DB and execute, not execute, but query. First one is my SQL statement, which I haven't created yet, I will. And the second one is the parameters, but I don't have any parameters right now. Let's create a SQL statement, which is select, to do, of course in quotes, select, to do, from list, from to-dos. And now I have the rows defined and I have the errors. Let's handle the error. And cannot add to do, but cannot list to do. Optionally, because this is the same text, you should like put as a const on the top. And there's a very important thing, defer rows close. If you're not doing this, you can get stuck with your database queries if you're running something else as well. So we have to close the rows all the time if everything is succeed. Okay, let's just iterate through and fill in the result string. This is a for loop. If I say for rows next, so rows next will return false if there's no more rows to process or an error happened. But if everything is fine, then I can scan the row value to a variable. So create a variable, and the variable will be a string because we were working with strings, and this is to do and string. We have something called row row scan, and we have to provide parameters, but it's very important, these parameters should be pointers. So I'm providing the to do. What happens here if I have the select to do, the first parameter, which is to do, will be scanned or assigned to this to do variable, but I need to use the pointer, otherwise it won't be able to do that. Okay, it returns with one error, and this error should be handled as usual. So just copy this, and the error is handled, and just add to our slice result equals append result and to do. And we are still not ready. You know, we need to do another check. This check will be if these rows returned with any error. So if I say if rows and error, this is the last error what happened, not equals nil, then I return the error again as usual. But if there is no error, then I can just return the result and nil. So this is the implementation of the database handling, and the only thing what we have to do is wire into our code. So let's go back to the app factory. If you remember, the app factory is responsible for building our dependencies. We used interfaces or contracts, and we have the to-do repository interface. And in the init storage, we used an environment variable, which we call storage. We already have the memory and the file done, so we just have to add into our factory the DB. Let's call it just DB. And it's not file new, but it has to be something which implements the storage interface. And this will be, we called it data store new. And it satisfies the interface, so everything looks fine. To the repository is not data store new. So in theory, our application should work. Let's clear this console and let's try to run. Go run. I'm expecting an error. Yes, we have an error because we don't have the environment variable set storage. So let's try out if I say export storage equals db and try to run again, then I don't have error anymore. So I can say add db to do 1, and there is an error. To-dos doesn't exist, so something is wrong with my database. Okay, so let's fix this. We have the to-do table, but it should be to-dos. So I'm just going to do something nasty now. We'll change an existing migration. So let's first roll back the existing table, migrate a rollback, and it's rolled back the to-do table. Then rename the drop tag to to-dos, and rename the create table to to-dos, and migrate again. And in theory, now my table called to-dos. Try to run again and add db to do 1, add db to do 2, and list. And it looks like it works. Add db to do 3, list, and that works, and quit. So our application is ready. Because we use the interfaces and abstraction, we easily could add a new layer, and we could create that new layer within our factory class as well. And now we have 5 file memory and a data storage as well. In the next episode, we will move into a different subject, and we will create a new HTTP server, and we'll see how we can serve information, serve data. Then in the next episode, we will working on JSONs, creating JSONs from string and back and from structs, so on. We will touch base on migrations and not migrations, on middlewares as well. And when we have all of these knowledges, we will start to modify our to-do application, and it's going to be an API in the next iteration. So see you in the next episode. Don't forget to subscribe if you'd like to see how it's done. Goodbye.